assignments, doubts, exams. We have got you back. EduPlanner make every chapter easy to understand. Stay tuned, learn more, grow with us.
So we're first going to note that the initial angle is going to be equal to 7 degrees, or we can say 0.122 radians. We can then say that if we're going to approximate the initial stretch of the spring as the arc length that corresponds to the point on the plate that the plate has moved through. So we can say x is equaling r times the initial angle, where r is equaling 0.025 meters. Then we can say that the initial potential energy, U, is going to be equal to 1/2 kx squared. We know that here the spring constant is 2,000 newtons per meter, and then this would be multiplied by 0.025 meters multiplied by 0.122 radians, quantity squared, and we can say that the initial potential energy would then be equal to 0.0093 joules. Now, this should be equal to the kinetic energy of the plate, knowing that the kinetic energy of the plate is going to be 1/2 times the moment of inertia times the maximum angular speed squared. And so this is the maximum angular speed, remember, not the angular frequency. So we can then say that the maximum angular speed would be equal to the maximum angular frequency multiplied by the initial angle, where the maximum angular frequency, this would be 2 pi divided by t, the period. And we know that t is equaling we can say 20 milliseconds, or not meters per second, milliseconds. This would equal 0.02 seconds. And so we can then see that here 1/2 I omega m squared would be equal to 0.0093 joules. And then we're simply solving for the moment of inertia, knowing that the moment of inertia is going to be equal to 2 times this kinetic energy divided by the maximum angular speed squared. This would be equal to 2 times k divided by the angular frequency times the initial angle quantity squared. So again, let's write that. I equals 2k divided by omega. This would be squared. And this is going to be equal to 2k divided by 2 pi over t multiplied by the initial angle squared. So this would be 2 times the kinetic energy of 0.0093 joules. This would be divided by 2 pi divided by 0.02 seconds multiplied by 0.122 radians, quantity squared, and we find that the moment of inertia is then equaling 1.3 times 10 to the -5th kilograms meters squared. This would be our final answer. That is the end of the solution. Thank you for watching.